Alright, let's go ahead and see how the back propagation work. Mainly, we have previously seen how feed-forward neural network work. I mean to say that in previous lectures, I told you that how information is flowing in forward direction. That means from input layer to hidden layer to the output layer. And the same thing I explained you earlier, how the information is flowing from input layer to hidden layer 1 and to hidden layer 2 and then hidden layer 3 and then finally output layer. But as simple this seems, this is not that much simple. Because let's say any input is given here and the output is coming here, how these neural networks or how the weights which are here getting trained, how these weights will know that how they need to set so that the output will match our target output. So I'm talking about the weights, which are these. When you have input, these gets multiplied by the weight, and then finally all these get summed together, and then finally there is the bias. Now if you see this and you compare this neural network where a lot of inputs are coming, alright, so do you see there, this is kind of a single unit where all these inputs are coming and then finally there are weights there. So in between these lines you can also assume that there are weights which are getting multiplied by the weights, and then finally there is the bias term. Once that is done, then there is the output. So the output, the same output will go to all of these layers, all of these neurons there. But we need to understand that what is the back propagation. So suppose that your input is this layer, input layer is this one, and then the hidden layer, and there are many hidden layers inside that. So information is flowing to the output. But the problem is, suppose that this one is your target output, but the prediction is happening which is a little off of the actual prediction. So there is some difference between the actual prediction and the actual output. So there is a difference between the prediction and the actual data or actual output. So we need to reset, we need to adjust our weights there in between, whatever your models are learning there. So we need to tell the previous layer, let's say this is the output layer, so we need to tell this layer to adjust your weight. So what happens here, whatever the output is there, then these outputs are compared with the actual output or the true output during the training. When there is the difference, then it sends a signal to the previous layer that you need to readjust your weight because our output and the true output and the predicted output is not matching. So the same thing happens here once again. Whatever the output, if output is not matching, then it sends again information to the previous layer. So the previous layer also need to set their weight, and this happens till the input layer. Alright, so the process of doing this is known as the back propagation process. That means when information when information moves from backward to the forward side, that is the known as the back propagation. So there are two type of the propagation here. One is the feed forward neural network, and then this is the back propagation. So the feed forward where the information is moving from input layer to the output layer. But in this network, the information also moves from the output layer toward the input layer so that the weights can be adjusted there. Here are some terms about the back propagation. So the feed forward, as I told you, that when information passes from input layer to output layer, that is known as the feed forward. Thereafter you have the calculation of the error. So the error is calculated here. So this you can say that how back propagation algorithm works there. So the first information moves in the feed forward way from input to output, and then the error is calculated, and then the back propagation of this error happens. This goes backward and tells this neural network to readjust your weight. Once readjustment of the weights happens, then the retraining happens again. So that's the repeat process. Alright, after the repeat process, it again adjusts their weight. Now you see there is the mention of the gradient descent. So actually, when I say that the adjustment of the weight, so adjustment of the weight doesn't happen like just plus minus. It is the very complicated process. So there are ways, or there are standard method, a mathematical formula to adjust those weight. So those methods we will be learning in coming lessons, and one of those method is gradient descent method, where we need to find out the lowest point. So the lowest point means the lowest error, and there is the loss function. So the loss function is something when information is moving from input layer to the output layer. So what information is lost when we compare predicted output and the true output. So we make there a mathematical formula which is known as a loss function. So based on that loss function, we calculate how much loss is there. So when loss is minimum, that means these two outputs are overlapping to each other. That means a perfect output is predicted there. So the loss should be zero in real world or in ideal case, although that ideal case doesn't happen always there. Alright. So there are other processes like the activation function, as we have already discussed. Then stochastic gradient descent. So this is also another way of doing the gradient descent, or you can say that it is just another version of a gradient descent. Thereafter we have a mini batch gradient descent. When we talk about the adjustment of the weight, in general it is happening for all data at once, but in practice that doesn't happen. So we do that with a small batch size. Suppose that your input have 100 data points or 100 rows there. So we don't do with all 100 rows at once. We set batch size like 32 and 64 batches at once, and then we train our models on those batches and then readjust our weights to with the help of those batches. So that's how it is known as a mini batch gradient descent. This is also there is the momentum. So this momentum is also used to improve the speed of convergence. So speed of convergence means how fast your neural network is predicting the true output there. Alright, that means how fast your neural network is reducing your error. So that is the momentum there. And the adaptive learning rate. So this is another technique of training your model. So in start, you can keep a large learning rate so that your model learns quickly all these weights there. All these weights can learn quickly, and thereafter you can reduce your learning rate, or you can change your learning rate with some formula. So that is known as the adaptive learning rate. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one.